In this video, we're going to talk about a type of factoring which is called the difference of two squares. So, as we know, factoring is reversing multiplication. So before we look at factoring question, we're going to review the multiplication question which we did before. So if we want to multiply a plus b times a minus b. Notice a and a, b and b, they're the same except the sign in front of b are different. One is plus, one is minus. So we are going to use FOIL or just distribution. So we're going to suppose to multiply this a with this a. So a times, notice multiplication is between the parentheses. We're going to do a times a, which gives us a squared. And then we're going to do a times negative b, which gives us minus ab. After we're done multiplying a, now we're going to multiply b times a. That should give us a ba, positive ba. But we're gonna write them in alphabetic order. So instead of having a ba, we're gonna change it to a times b, because b times a is the same as a times b. And then we're gonna do b times negative b. As we know, a positive times negative will still be negative, but b times b is going to give us a b squared. And if we take a look and try to simplify this, a squared will stay as a squared and b squared will stay as b squared. But negative ab and positive ab, they cancel each other. So these two will be canceled out. This multiplication is a special type of multiplication because the two terms in the middle always cancel out. This does not always happen. This only happens when we have when you multiply a plus b times a minus b. We do have a name for this special type. We call them conjugate. So when we do factoring, we're reversing this process. So what we are given will be a squared minus b squared. The answer from multiplication that we just got. So this will become our problem, our question now. So a squared minus b squared. And again, the reason we call this type the difference of two squares. So let me put the type here. It's called the difference of two squares. Comes from the multiplication, the answer here. As you can see, after we multiply a plus b and a minus b, we got exactly the difference, because minus means difference. There's a minus here, and we got a squared b squared, which is exactly two squares. That's why we call this type the difference of two squares. So when we're trying to go back, as you can see, what times what? We're supposed to fill in the blank here. So what times what is going to be equal to a squared minus b squared? As you can see, we multiplied a plus b and a minus b. That's how we got a squared minus b squared. So what we should put here is a plus b times a minus b, or a minus b times a plus b. Because multiplication has commutative property, if you switch them, you're still going to get the same thing. So the next question is, we want to memorize this formula without doing multiplication that we just did every single time. So how do we memorize this formula? Well, from the process we just did, multiplication process, how did we get a squared? It's 1a in the first pair of parentheses and 1a in the second pair. When we multiply them, we got a squared. How did we get this minus right here? It's positive b times negative b, and a positive times negative give us a negative. And similarly, this b squared comes from multiplying b times b. So when we memorize this process, this formula, we can go backwards. So where does a squared come from? It comes from a times in the middle, a. And where does this minus come from? It comes from a positive times a negative. And where does the b squared come from? It comes from b times another b. Well, notice that the two ones we didn't really care because they always cancel each other in this case. So this is how we memorize the formula. Try to figure out what times what is a squared. It's a times a. And how we get a minus between them, it's positive times a negative. And how do we get b squared? Similarly, it's b times b. Okay, so now memorize. Later, you don't have to look at the multiplication anymore, like how we got this formula. But I use this multiplication to help you understand the process of factoring, reversing multiplication. So hopefully you can memorize this formula now. So now we can look at an example, how we use the formula to factor this type.